Okay, guys, we start our first class. Please be prepared. We start from problem 1 about perfect competition and equilibrium on a perfectly competitive market. Let's see what we have here. Easy task from your high school if you studied economics. So I think you will answer for me anything from this task. Okay, consider a market with consumers indexed by 1, 2, and two firms indexed by 1, 2. The consumer's I's inverse demand function is I minus Q, and the firm's G's cost function is C equal to G divided by 2. First point, we should find the inverse market demand function. What we should do, we should work with our consumers. Yes. We have two consumers. Okay, let's start from consumer 1. Its inverse demand function is 1 minus Q. And this is inverse demand function. First of all, we should find demand function. It's 1 minus P, yes, Q1. And this is true only if prices are lower or equal than 1. Why is it so? Because we consume only a positive amount of good. Yes, we cannot consume minus 1 banana. Yes, so this Q should be greater or equal than 0. That's why prices should be less or equal than 1. Yes, so and my demand of consumer 1 should be equal to 0 if price greater than 1. Yes, so this is the demand function for consumer 1. Same way, let us find the demand function for consumer 2. It's 2 minus P if price less or equal than 2, and 0 if price greater than 2. So now we should find market demand function. How to find it? Market demand function, Q capital, yes, is a function of price. This is the sum of two demands, of demand of first consumer as a function of price plus the demand of second consumer as a function of price. So how we should sum up our demand functions? This will be system of equations. Yes, and we should start, when we sum up demands, we start from price infinity and then go lower to price 0. So if price is very, very big, nobody demands the good. So our demand will be equal to 0. For which prices? Who can answer? For all consumers.
More than 2.
More than 2, yes, exactly. So if price more than 2, nobody demands. Yes. Then we see that we have this interval of prices between 2 and 1. Yes. And in this interval of prices, only second consumer demands. So here will be 2 minus P if price belongs from 1 to 2. And then if price belongs from 0 to 1, both consumers demand the good. So we should sum up their demands. So here 1 minus P plus 2 minus P. This will be 3 minus 2P. So now we found their market demand function. Easy. Please, questions? Okay, we will continue. B. In point B, we should find the market supply function. So market supply is a function of price. So, and this will be the sum of supplies of two firms. Yes. what we should do? We should find the supply function for each firm. Let's start from the first firm, firm 1. How firm decides how much to supply from her profit maximization problem. So for firm 1, profit will be revenue. It's price constant multiplied by quantity minus costs. For the first firm, it is how much Q over 2. Yes, and this we should maximize by choosing quantity greater or equal than 0. Here we see that profit is a linear function. Yes, profit. Okay, let's do like this: P minus 1/2 multiplied by quantity. This is the profit of the first firm, and we see that this is linear function. And how we will maximize it? Easy. Yes. For different prices, we will choose different quantities. For example, if price, okay, let's quantity for the first firm as a function will be equal to, if the price is greater than 1/2. So you see that we will have a linear function with positive slope. So the higher the quantity, the higher the price. Yes. So what will be our choice of quantity that we will produce? We want to produce more and more. Yes, because if we produce more, our profit increases. So here will be plus infinity. Then let's do here. If price less than 1/2, we see that we will have negative slope of profit function. And what we should do, how much we will produce, the more we produce, the lower our profit. Yes. So we will not produce, we will produce 0. We do not want this a lower profit. Yes. And last, if price equal to 1/2, our profit equals to 0. And we do not care how much to produce. Profit will be constant, it will be 0. So we can choose any amount from 0 to infinity. So this is the supply of the first firm. Next. For the second firm, profit of the second firm is revenue, price multiplied by quantity. Yes, minus costs. Let's see costs of the second firm. Q in power of j, and we have second firm, so it will be Q in power of 2 over 2. And this we will maximize by choosing quantity greater or equal than 0. The profit of the second firm is a quadratic function with a graph parabola branches down. Yes, so it will be like this. So we will have maximum. Yes, if we'll find quantity, optimal quantity. But in your class, we should write down first order condition. Yes, this is the first derivative should be equal to 0 or less than equal to 0. This will be price minus Q should be equal to 0. Yes, and from here, quantity equals to price. And second order condition, second derivative should be less or equal than 0. And we check it. Second derivative by Q, yes, it is minus 1. It is less than 0. So, okay, for maximum, second order condition holds. And this second order condition is the same that we speak about parabola branches down. So we found maximum of profit. So, question? So from here.
Yes, I'm sorry. I'm sorry, I have a question in the second line of the equation of QS. We have from 0 to plus infinity, and so why I cannot understand, because if we put ну, 1/2 equation of profit one, it will be only 0.
Mhm.
So why we have a plus infinity?
Okay, one more time. If price is equal to 1/2, profit will be 0. It is constant. Yes, profit constant. So how much we will produce if our profit always constant? We do not care how much we will produce. We can produce one unit, profit will be 0. We can produce 50 units, profit will be 0. We can produce, I don't know, 100 units, profit will be 0.
Okay,
Yes?
thank you. Yes, understand.
Here, and we can choose any quantity from interval from 0 to plus infinity, because profit will be 0 every time. Yes. Okay. So for the second term, the supply function will be equal
Sorry,
to.
I have a question too.
Please. Who had question? Please. Okay.
Part of this x equal in we just summarized two previous equals, like 1 minus p and 2 minus p, to get this period of numbers from 0 to 1, or what?
Yes, exactly. So if price is between 0 and 1, yes, both consumers demand, yes, the good. So because here, if price less or equal to 1, we have demand, yes, positive demand. And here, if price less than 1, we have positive demand. Yes, so we sum up 3 minus 2p, it's from 1 minus p plus 2 minus p. Yes.
Yeah, it's clear. Thank you.
Okay. So here, what we will have. Then we should find total supply. Yes, and we will do the same as in our demand. Yes, but we begin to sum up from prices from 0 to infinity. Yes, from down to up. Okay, let's do it. Who supply when price is 0? We see only second, yes, firm, only second firm supplies. So we'll have quantity supplied will be equal to P from the second firm if price less than how much? First firm begins to supply from 1/2. Yes, so if price is less than 1/2, only second firm supplies. Then what we will have? If price is equal to 1/2, what we will sum up? We see that the second firm, how much it supplies when price is 1/2. If price is 1/2, quantity supplied by the second firm is 1/2. Yes, and the first firm supplies any number from 0 to plus infinity. Yes, so here we will have 1/2 plus from 0 to plus infinity. So it will be from 1/2 to plus infinity. And then if price greater than 1/2, what we will have? First firm supplies plus infinity, second firm supplies something, yes, that greater than 1/2. But if we sum up plus infinity with any number, we will have plus infinity, yes, from mathematics. So here will be plus infinity. This was analytically. Now let's do everything. With the graph, and it will be our point C. What I should do? I should erase, maybe. No. Let's do it. I have no space. Okay, I will erase something. Let's raise. Oh. Let's raise this one here. So this will be point C when we should find equilibrium. In equilibrium situation, we should cross market demand and market supply. Yes. So here will be quantity demanded by all consumers should be equal to quantity supplied by all firms. Let's do it graphically, first of all, and then analytically. So here will be market quantity, here dollar, yes. And let's start from demand. Demand, 0 if price greater than 2. Yes, 0 if price greater than 2. Then 2 minus P if price from 1 to 2. So something like this, 2, 1. 2 minus P, slope equals to 1. Here would be 1, yes. And then 3 minus 2P if price from 0 to 1. So if price is equal to 0, our quantity supplied by all firms is equal to 3. So here will be 3. And slope is flatter, yes. So this is the demand, market demand. What about market supply? Market supply, let's see. Market supply is equal to P if price less than 1/2. So we should put the price 1/2. What is P? P is linear function with positive slope, yes, and it is from 0, 0. If price is equal to 1/2, quantity is equal to 1/2, yes, something like this. Then quantity supplied by all firms will be any number from 1/2 to plus infinity. So it is horizontal line, yes, if price is equal to 1/2. And quantity supplied is equal to plus infinity if price greater than 1/2. What that means? That means that on the graph we cannot draw plus infinity. Yes. So, and with equilibrium we have here, yes. And we exactly see that equilibrium price will be equal to 1/2, and which interval we should use for demand, where it crosses price equals to 1/2. The last one, yes, where? This one, yes. So we write down that equilibrium price is equal to 1/2, and equilibrium quantity is equal, we put this 1/2 into demand, and this will be 3 minus 2 multiplied by 1/2 is equal to 2. So answer. If we should find equilibrium, we should write down two things: price equals to 1/2 and quantity equals to 2. So this is the end of the first task. Guys, please, questions, ask for this task.
Yes. How did we understand that the second term Q is equal to P from our first order condition?
Yes, from the first order condition, you see, first derivative is equal to, take the first derivative. So here we take the derivative by Q, it is equal to P as constant, yes. And here we take the first derivative Q, yes, we will get. So this is derivative by Q, because we maximize by quantity. Agree? So P minus Q equals to 0. So from here, we find that quantity is equal to P from first order condition. Agree?
Thank you.
Okay, let's move on. what we will have, sorry. What we will have in the second task. Let's read. Second task. Consider a market with an inverse market demand function 2 minus q. And okay, 2 minus q. The market hosts one firm with a cost function that looks like this. And the first task, suppose the firm is a price taker, find the supply function. Price taker, that means that we speak about perfectly competitive market. What that means? That means that price for us will be constant. Yes, we're not monopoly now. Let us solve for price taker. Point A, price taker. That means that price is constant. So how we will find the supply function? From profit maximization program, yes, as always. So we write down profit maximization program for our firm. It's revenue, total revenue, it's price multiplied by quantity, minus total costs. Total costs here, q power 3 over 3 minus q square over 2 plus q. So these are total costs. Yes, and this we should maximize by choosing quantity greater or equal than 0. When you start your task, when you will solve your homework or something like this, you should always write down a maximization program or utility maximization program. So first of all, you should write down what you will solve. Yes, and by which thing you will maximize. Yes. So okay, first of all, first order condition. We should find critical points. Yes, first order condition. First order condition. First derivative by quantity should be equal to 0 or less or equal than 0. Yes. So let's take the first derivative. Its price is constant minus q square plus q minus 1. This should be equal to 0, or price equals to q square minus q plus 1. So this is exactly the derivative from total costs, and we call it marginal costs. Yes, and this price. Okay, then we should check second order condition. Second order condition that we found maximum, not minimum of profit. For maximum, second derivative should be less or equal than 0. So let us take second derivative. This should be minus 2q plus 1, and this should be less or equal than 0. So for which quantities, that's true. For quantities greater or equal than 1/2. Yes, for maximum. For maximum. So then we should find quantities quantities supplied. Yes, and we will find it from first order condition. But in first order condition, now we have something like inverse supply function. Yes, so from here we should find quantity. Yes, let us inverse our function. Let's do it. So from here, q square minus q plus 1 minus p equals to 0. It is quadratic equation. Our price is constant, so look at it like constant. And we solve for quadratic equation. Q will be equal to, you remember, minus b plus the square root out of d over to a. Yes, so minus b is 1 plus minus square root out of b square 1 minus 4 multiplied by 1 minus p. over 2a over 2. Yes. And we should, first of all, we should check that our d, that is under the square root, yes, is greater than 0, greater or equal than 0. So d equals to 1 minus 4, 1 minus p, greater or equal than 0. So this is true for which prices? 1 minus 4 plus 4p greater or equal than 0. So this is true for prices greater or equal than 3 over 4. Yes, it's first. Then, now we found two roots, 1 and 2, and we should choose the right root that we need. Yes, what we see in second order condition, we see that quantity should be greater or equal than 1/2. And in our roots, you see we have 1/2. Yes, and in the first root with plus, we sum something positive. Yes, we do plus something positive. So the first root will be greater than 1/2, and second root with minus, we do minus something positive. Yes, because square root is positive. So square root with minus, we will not choose. Yes, so only quantity equals to 1 plus square root of 1 minus 4, 1 minus price over 2 is greater than 1/2, greater or equal than 1/2. Yes, and second root we will not choose. So here, okay. Yes. This was first order condition and second order condition. Then the last condition that we should check, it is shutdown condition. What that means? This condition means that even if we have quantity that we want to produce, maybe in some situations, this quantity will bring us profit less than 0 and very, very big losses. Yes, that means that for producing something, our profit with optimal quantity should be greater or equal than profit if we do not produce anything. Yes, this is shutdown condition. So if this condition not true, we will shut down. Yes, so with this condition, we produce. So here, what that means, in general, we have profit price multiplied by quantity revenue minus total costs. Yes, this should be equal than greater or equal than what? 0. Put quantity equals to 0 into profit. 0 minus costs out of 0. Let's see in our task, we see that our costs, or all our costs, are variable costs. Yes, we do not have fixed costs, we do not have constants, so we will have here 0 now. Yes, so this will be 0 in our task as we have no fixed costs. So then price multiplied by quantity greater or equal than total costs. Yes, put then price greater than equal than costs over quantity. And this, you know what that means. This is average costs, or in our task, they are equal to average variable costs because we do not have fixed costs. This one. Here, explanation. So we should find price that greater or equal than average variable costs. But what we also know from first order condition, we know that the price equals to what? Marginal costs. Yes, so price here equals to marginal costs for a perfectly competitive firm. So we know the function for marginal costs, and we now can find the function for average variable costs. Let's do it. We divide our total cost by Q. Yes, this will be Q square over 3 minus Q over 2 plus 1. Yes, and we know marginal costs. Marginal costs will be Q square minus Q plus 1. And now we should equalize them. So let's do it. So Q square minus Q plus 1 equals to Q square over 3 minus Q over 2 plus 1. Delete plus 1 and delete Q. Yes, one time. Then what will have Q minus 1 equals to Q over 3 minus 1/2. And here we see that we will have 2/3 Q equals to 1/2. And this is Q equals to 3 over 4. Q equals to 3 over 4. What that means? That means that we will have minimum of average variable costs if quantity is equal to 3 over 4. I will draw it for you for understanding. So here will be quantity, here everything that we count in dollars, and marginal costs, we see that it is quadratic function. It will look like this. I don't know how it will look, but something like this, yes? And average variable costs, we can prove, and we know for all functions that it crosses marginal costs in minimum of average variable costs. So this will be like this. And when marginal costs and average variable costs are equal, this is true when quantity is equal to 3 over 4. Yes. Also, we know that from second order condition, that minimum of marginal costs will be when quantity is equal to 1/2. It's from SOC. But anyway, now we should say that price, see, that price should be greater or equal than minimum of average variable costs. Let's write here, price should be greater or equal than minimum of average variable costs. And we know that this minimum is when quantity is equal to 3 over 4. So put this quantity 3 over 4 into average variable cost function. So minimum of average variable costs equals to average variable costs out of 3 over 4. Yes, put it 3 over 4 square over 3 minus 3 over 4 multiplied by 2 plus 1. And this is equal to 13 over 16. So here on our graph, this price, minimal price will be 13 over 16. So on our graph, we can draw now inverse supply function for our firm if it is perfectly competitive. We will not produce if price is less than 13 over 16. So our quantity supplied will be equal to 0. And then when price is bigger than 13 over 16, we will produce price equals to marginal costs. Yes, we will produce on the upward part of marginal cost function. So this is inverse supply function for our firm. Now we're ready to write down supply function for our firm. Let's do it. For example, we're here. So now we're ready to do it. So quantity supplied for our function. So I draw now here. As a function of price will be equal to 0 if price is less than 13 over 16, and then 1 from first to the condition, this red one, this one, 1 plus square root out of 1 minus 4, 1 minus price, yes, over 2. This is true if price bigger than 13 over 16, like this. So this is the supply of perfectly competitive firm with such costs. Guys, please ask right now, and I will erase. Everything is clear? Okay, I can
What
say,
is, can I ask? What
please
if
ask.
our, yes, what if our cost was a number, for example, 2, then our average variable cost wouldn't be equal to average cost, right?
I didn't hear what you told. Please, one more time. You can say in Russian for better understanding.
Если бы у нас изначально наш кост имел какую-то цифру, ну, допустим, 2, а не функцию, тогда бы наш average cost, он бы не был равен, да? Average variable cost.
Да. Смотрите, давайте отвечу, да, если вопрос на русском, давайте на русском отвечу. Значит, что мы знаем про нашу функцию издержек, да, там ТЦ? Это у нас переменные издержки, variable costs, да, и фиксированные издержки, fixed costs. Соответственно, средние издержки, average costs, это общие, да, разделить на количество. Да, соответственно, это переменные, variable на количество, плюс постоянные на количество. Правильно? Вот. И что тогда получается? Да, это у нас средние переменные издержки, average variable costs, плюс средние постоянные издержки, average fixed costs. Но сейчас у нас, да, в нашем задании нет постоянных издержек, нет констант. Что такое постоянные издержки? Это наши общие издержки, если мы ничего не производим. Ну, подставьте, да, в наши общие издержки вот сюда, подставьте 0, да, и мы ничего не производим, у нас нет, да, постоянных издержек. Вот, соответственно, да, получается, что сейчас у нас они равны. Правильно? Так, ответила на вопрос?
Да, спасибо.
Okay. Okay, let us move on. I will erase all these. In the point B, we should find competitive quantity price pair, what that means. So in point B, we should find equilibrium in perfectly competitive market. So as always, we should equalize quantity demanded and quantity supplied. Yes, what we know about demand. Inverse demand function is equal to 2 minus Q, it's from the task. Quantity supplied equals to, we found it, yes, in point A, this one. But let us draw it on our graph. 2 minus Q, our quantity supplied, our quantity demanded, but inverse demand function. So here will be 2, and here will be 2. So this is the demand. And we see that it crosses our supply function somewhere when marginal costs have upward part. Yes. So let us, for simplicity, let us equalize inverse demand and inverse supply function for not working with this square root. Yes, but you can work with it. So first you can equalize quantity demanded is 2 minus P. Yes, this Q T. And quantity supplied is 1 plus square root of 1 minus 4, 1 minus P, yes, over 2. And from here you will find price for which this is true. This is quantity supplied for our. But also in here we can equalize inverse demand and supply functions. How we will do it? inverse demand 2 minus Q. This is PD. Inverse supply function, this is marginal cost function. Yes, marginal cost function was Q square minus Q plus 1. This is PS equals to marginal cost function. That's from the first point. So here, what we will delete minus Q. Yes, and from here, we see that Q will be equal to how much? Q square equals to 1. Yes, so Q will be equal to 1 also. And price, equilibrium price, will be equal to put into demand, inverse demand out of 1 will be equal to 2 minus 1 equals to 1. So answer for this task for second for point B. Yes, Q equals to 1, P equals to 1. So this is perfectly competitive equilibrium. So here questions, please. Yes. Easy. Yes.
How do we translate competitive quantity price?
Competitive quantity price. This one. Yes. Green. So we found equilibrium quantity. It's on our two minus 1 equals to 1. Yes. So here also 1 on our graph. So this is perfectly competitive equilibrium. Clear? No? Please?
Yes, thank you.
Okay, thank you. So we move on. I erase everything because now we will find everything for monopoly. Let's do it. If we speak about monopoly in the market, it's not perfectly competitive market now. Our monopoly is price maker. Yes, this is the definition of monopolist. So now, in point C, we will find the optimum monopoly quantity price pair. So if we speak about monopoly, it is price maker. So for monopoly, price in total revenue is not constant anymore. Yes, our monopolist, it controls demand. It controls demand of all consumers. Yes. So in our profit for monopolist, here will be not price constant, but inverse demand function minus total cost. Yes, let's put everything. So 2 minus Q multiplied by Q minus total costs. Total costs, Q power 3 over 3 minus Q square over 2 plus Q. And this our monopolist maximizes by choosing quantity greater or equal than 0. Yes, so here, this is total revenue. This is total costs, or as you wrote, C out of Q. Yes, it's the same synonyms. Yes, first order condition. First order condition. Our first derivative should be equal to 0. If we will speak in general, yes. So this is total revenue prime minus total cost prime should be equal to 0. The first derivative out of total revenue is marginal revenue. Yes. And the first derivative from total costs, marginal cost. So this is the first order condition for monopolist. Yes. Okay, let's take derivatives. Let's take derivatives. It will be 2 minus 2Q. Yes, marginal revenue. equals to marginal cost. Marginal cost we calculated, it's q square minus q plus 1 marginal cost. So we should solve it, and from here we will find quantity, equilibrium quantity for monopolist. So let's do it. So, q square plus q minus 1 should be equal to 0. Yes, quadratic equation. Am I right? Yes. So from here we will have two roots. Yes, this will be minus 1 plus minus square root out of 1 square. Yes, b square 1 square plus 4. That's all. Yes, over 2. So this will be square root out of 5 plus minus 1 over 2. And now we should choose, which root we need. Yes. Then now we cannot choose. Yes, because they both greater than 0, so we do not know. How we will choose? We will take second order condition. We will check second order condition. Second derivative for maximum should be less or equal than 0. Yes, let's do it. Second order condition. Or in our terms, marginal revenue prime minus marginal cost prime should be less or equal than 0. What that means? That means that the slope of marginal revenue should be less or equal than the slope of marginal cost function. Let's check it. The slope of marginal revenue, we see that marginal revenue is linear function with negative slope. Yes, marginal cost function, it's a graph parabola, so we do not know the slope right now. So, but we can check everything. So the slope of marginal revenue is minus 2, take the derivative, yes, less or equal, then the slope of marginal cost is 2q minus 1. Yes, I took derivatives. So here, 2q greater or equal than minus 1, so q greater or equal than minus 1/2. So now it didn't help us, yes? What we then should do? So both these roots from first order condition, they are greater or equal than minus 1/2, yes? So what we should do? We should check a third condition. It is shutdown condition, shutdown. Let's check it. We remember this shutdown condition. I will not write it a second time. This is price greater or equal than minimum of here or of average variable cost.
А можно вопрос?
Please.
Почему там, ну, когда вот вы написали Q1, 2 равно вот этому, а потом вы поменяли местами корень из 5 и 1, и получилось как бы, что, ну, там должно быть у одного знак минус, и тогда вообще получается, что один корень остается.
Да, спасибо большое. Сейчас, да, сделаем. Я поняла, давайте красным, да, что типа это вот ошибка, я сейчас буду исправлять. Значит, тут действительно, когда я поменяла местами, тут должно остаться плюс-минус, да, а тут должен минус быть, правильно? Да. Вот, и тогда у нас один корень, скорее всего, только один корень, скорее всего, подходит. Правильно? Остается. Да, спасибо, хорошее замечание. Так, давайте проверим. Да, то есть проверим корень, минус корень из 5, минус 1 разделить на 2. Вот, и надо его сравнить с 1/2, с минус 1/2. Да, если тут двойки зачеркнем, да, и минус 1 зачеркнем, да, получается, что минус корень из 5 меньше, да, 0. Вот, то есть действительно нам второй корень не подходит, и остается только первый корень. Правильно? Да, спасибо большое. Тогда давайте, значит, сюда я запишу. Следовательно, нам пока, да, подходит корень Q с плюсом, да, корень из 5 минус 1 на 2. Вот так. Согласны? Так, согласились? Голосовали? Вот. Но в любом случае нам нужно проверить, да, вот этот будет shutdown, да, когда, это же у нас для монополиста, да, количество, которое он будет продавать. Okay, let's continue in English. So, yes, thank you. We found the mistake, yes, and we found that only one root we choose, yes, only one root is greater or equal than -1/2, And this is the quantity that monopolist will produce. Yes. So then let us remember the definition of monopolist. Monopolist is price maker. So monopolist chose the quantity that it will produce, and now monopolist should choose the price. How he will do it? Easy. Yes, he will choose the price as maximum willingness to pay for such quantity. As maximum willingness to pay. So we will put, and maximum willingness to pay is the definition of inverse demand function. Yes. So let's put it into where, okay, I will write here this. Let's put, to find monopolist price, we should put into inverse demand function our equilibrium quantity, yes, as maximum willingness to pay. And this will be how much? 2 minus q, 2 minus this one square root 5 minus 1 over 2. And this is 4 plus 1, 5, yes, minus square root of 5 over 2. Agree? Yes. And the last. So this is the price. And the last, we should check this shutdown condition, that the price greater or equal than minimum of average variable costs. But we know this minimum of average variable costs should be greater or equal than minimum of average variable costs. And this is how much? 13 over 16. We counted it in point A, because the same firm, same costs, yes, for the firm. And I counted it for you. 5 minus square root out of 5 over 2, it is approximately 1.38, and 13 over 16, it is approximately 0.8. So that's true. And monopolist will produce this quantity. So this is true. So answer, we're ready to write down the answer for monopolist. For monopolist, quantity is square root out of 5 minus 1 over 2. Price is 5 minus square root out of 5 over 2. This is answer for this task. Here, minus. Guys, please, questions about this task?
Price is 5.
One more time.
Can you please repeat the answer for price?
How we found the price, yes?
Yes.
So how monopolist decides which price to put? So let me show you easy example. Yes, somewhere here. So this is excess. Yes. For example, this is the demand. Then marginal revenue would be like this, marginal revenue. And for example, costs like this, marginal costs. Our first order condition, marginal revenue equals to marginal costs. It's here. From this condition, we found quantity, optimal quantity. And then monopolist wants to put the price. Yes, wants to charge the price. And monopolist will choose the highest price that consumers will pay. The highest price is where this quantity crosses the demand. Yes. So this will be optimal price of monopolist, because if it will charge higher price, nobody will buy for this quantity for such price. Agree? So this is the maximal price that for which consumers will buy the good. So that's why this is the demand function. This is the inverse demand function. So we put here for finding optimal price, we put our optimal quantity that we found into inverse demand function. Inverse demand function, remember, it's 2 minus Q star. It's from the task, This is our quantity, Q star. And we solve it and found the price. Clear? No?
Yes, thank you.
Okay, so good. Oh, we have time to solve the last task. That's super cool. I thought that we will not have time. So let's do it. Problem three. I will prove it for you. Let's do it. So let's read. Consider market for mobile phones, which hosts a single firm. Single firm, that means monopoly. Single firm means monopoly. Yes. Suppose you have already estimated the market demand function, 1 minus p squared, but you have no clue what firm's costs are. We do not know cost function. Orange Inc. Can Orange Inc. be a profit maximizing monopoly if her total sales are 3 or 4? We should check it. Yes. So let's do it. What do you know about monopoly? Monopoly works. Maybe somebody know how to prove it, how to solve this task, please. Any suggestions? Okay, I will prove it for you. I will try to prove it. So, what we know about profit maximizing monopoly? Let's see. Profit maximizing monopoly maximizes the profit. Yes, so this will be inverse demand function as a function of quantity multiplied by quantity. This is total revenue. Yes, minus total cost, C out of Q. And this it should maximize by choosing quantity greater or equal than 0. And then we wrote first order condition. So the first derivative should be equal to 0 or less or equal to 0. So first derivative is let's do in general. Inverse demand function multiplied by quantity prime, yes, minus C prime out of Q. You see that in the first brackets we have two functions that depends on quantity. So this will be the derivative like this. The derivative of the first function is a function of Q multiplied by the quantity, yes, second function, plus the derivative from the second function. The derivative from Q is 1. Yes, multiplied by the first function. I hope you remember it from calculus. Yes, remember UV prime is U prime V plus VP prime U. Yes. Okay. So then minus this is what? The derivative from total costs, marginal costs. Yes, this marginal costs. So here will be minus marginal costs equals to 0. So let's write down. So this will be PD prime multiplied by Q plus PD equals to marginal costs. Let us put a price inverse demand function out of brackets in the left side. This will be inverse demand function here, PD prime multiplied by quantity over PD, yes, plus 1 equals to marginal costs. Agree? We can do like this. Yes. Then this formula is what? it is revert definition of elasticity. It is 1 over elasticity by module, here minus. Elasticity of the demand, let's do like this. Elasticity of the demand by price, by definition, it is how our demand changes in percents if we change the price in percents. And this is what? This is the change in quantity over quantity multiplied by 100% divided by the change in price over price multiplied by 100%. Yes, we can delete 100%, revert everything. And what we will see, the change in quantity in units over the change in price multiplied by the price over quantity. Yes, this is the definition of elasticity. How our quantity demanded changes if we change the price in percent. So, and this is the definition of derivative. Yes, if our changes are very, very small. So here what we'll have. This can be the derivative by price of the demand function, or this will be 1 over the derivative of inverse demand function. Yes, it's the same from calculus. And here we see in our brackets, this is the revert. This is the revert definition of elasticity. Yes, you see price, quantity, and the derivative for inverse demand function. So this is price. Here 1 over price prime multiplied by price over quantity. Yes, plus 1 equals to marginal cost. So this is elasticity. So price multiplied by 1 minus 1 over elasticity by module, elasticity of demand, equals to marginal cost. We know that definitely, this is first order condition. Definitely marginal costs are positive. Yes, price, inverse demand function, each price is positive. So this bracket should be also positive. This bracket should be also positive. Agree? So 1 minus 1 over elasticity should be greater or equal than 0. Yes, so if we will revert it, so module of elasticity should be greater or equal than 1. That means that monopoly works only on elastic part of the demand. Monopolist works at elastic part of demand. And here we can use it to check if this quantity 3 over 4 is optimal for us. Can we choose such quantity? Let's do it. Let's do it together. Let's check what we need for checking the elasticity. We need inverse demand function. Yes. So we have QD, yes, equals to 1 minus P square. Let's do inverse demand function. P square equals to 1 minus Q. So P equals to 1 minus Q in power of 1/2. Agree? So then what we also need? We need for elasticity, one more time, elasticity equals to 1 over price prime multiplied by price over quantity. Yes, we need derivative. We need derivative. Okay, let's do it here. We need derivative of inverse demand function. This will be 1/2 multiplied by 1 minus Q in power of 1 minus 1/2. Yes, this is 1 over 2, 1 minus Q in power of 1/2. Then So we're ready to write down the elasticity. It's 1 over 1 over 2, 1 minus q, to the power of 1/2. Then multiplied by price, and this is inverse demand function. Inverse demand function, 1 minus q multiplied by 1/2 over quantity. Yes, revert everything. This will be 2, 1 minus q over q. And we know that this elasticity by module should be, okay, I will write with other color. This elasticity of the demand by module should be greater or equal than 1. Let's check it. Let's check it. So 2 minus 2q over q should be greater or equal than 1. So 2 minus 2q greater or equal than q. So q should be less or equal than 2/3. You see? So monopolist will produce no more than 2/3. And let's check what we have in the task. We have 3 over 4. So let's write down q star equals to 3 over 4 is bigger than 2/3. Agree? Or am I right? I think yes. Yes. This is 9 over 12, and this is 8 over 12. So this is true. So that means that monopolist can produce such quantity. So the answer for this task is no. Please ask. I think that all these formulas you found in the lecture. Yes. Learner index, how to work with elasticity and monopoly. Agree? Are you agree with me? Do you agree with me? Or you see it for the first time? You had it in the lecture, yes?
Это было.
Okay, good.
А можно другое решение предложить? Я не знаю, просто оно рабочее или нет.
Пожалуйста.
Вот если обратную функцию, получается, то там с самого начала нам вверху дают функцию спроса, да? Если обратную сделать, это получается корень из 1 минус q, да? Если вот сразу на первое условие, то что маржинальная прибыль должна быть равна маржинальным затратам.
Предельная выручка, не прибыль, предельная выручка должна быть равна предельным издержкам. Так.
И если вот мы запишем предельную прибыль, это будет 1 минус q, корень 1 минус q. Можете записывать, потому что я как-то...
Давайте сейчас вот тут где-нибудь... Так, сейчас я что-нибудь сотру. Туда буду писать.
Получается, прибыль – это q умножить на корень 1 минус q. Я правильно понимаю?
Это не прибыль, это выручка, пожалуйста.
Ну, выручка, да, выручка, да.
Это
выручка.
очень разные вещи.
Да, я понимаю. Но это я просто, да, привык так. Выручка – это q умножить на корень 1 минус q, да?
Так, 1 минус q давайте, да, в степени 1/2 умножить на q. Так, хорошо. А предельная выручка?
Получается, предельная – это, ну, если взять, получается, как бы, то получается корень 1 минус q минус
еще надо минус, кстати, еще поставить. Вот, ребята, вот тут мы минус потеряли. Я когда брала производную, там еще надо на минус 1 умножить. Ну ладно, там на решение не повлияло, потому что все равно модуль берется, но в любом случае. Тут
ну да, вот если производную взять, как бы, то получается корень 1 минус q разделить на 2 корня 1 минус q.
Минус q на 2 корня на 1 минус q. Так, хорошо, и чего?
И плюс корень 1 минус q.
А, да, там еще плюс. Да,
Там, ну, там функция, получается, перемножается через q.
Плюс 1 минус q степени 1/2. Так, хорошо.
Да, и если подставить 3/4 сразу, то там получается отрицательное число. А вот как бы marginal cost не могут быть отрицательным числом. И поэтому...
Можно, да, почему нет? Да, тоже хорошее решение, супер, да, давайте галочку поставим. И скажем, да, то, что MR, вот мы посчитали MR от 3/4, да, у нас там, если подставить, получается меньше нуля, да,
минус 1/4 получается.
Давайте, да, равно минус 1/4, это меньше нуля, да, соответственно, а в фоке должно быть MR равно MC, а MC у нас положительное. Следовательно, противоречие, следовательно, ответ нет. Да, так тоже можно было. Вот. Но мне просто вам нужно было рассказать про связь с эластичностью.
Да,
вот сегодня на занятии, ну как повторить, да, но ваше решение тоже хорошее, да, очень неплохо. Вот, супер. Так, еще, пожалуйста, вопрос. Ну, вообще у нас уже закончился только что семинар, вот, но... Ну, хорошо. Ребята, давайте тогда, если что, пишите вот в Телеграме. Наверное, там в Телеграм-канале, наверное, что-то можно... Я сейчас заканчиваю. Вот, что-то можно там писать, обсуждать. И вот эту запись этого семинара я выложу. Вот. Но вот это то, что с iPad у меня, да, вот эти записи, их нет смысла выкладывать туда как файл, потому что я очень много стирала. Вот, да, так что я именно как видеозапись выложу. Хорошо? Вот.
Вы выложите в Телеграм-канал, да?
Да, я хочу в Телеграм-канал выкладывать. Вот, надеюсь, на него все подписались уже, кто здесь есть. Вот, ну, короче, ладно. Вот, все, коллеги, тут меня уже выгоняют. Давайте прощаться с вами. Вот до следующей пятницы. И что, пишите. Вот, ладно. Все.
Спасибо,
Пока.
До свидания.
До свидания.